Okay, so for this question, we want to find the coordinate of the turning point on the curve y equals sine cube of x multiplied by cos x for 0 is less than x and x is less than pi. And we also have to determine which point gives a maximum value of y. So let us start by finding the turning point on this curve. So we know that at turning point, y prime should be equal to what? Y prime should be equal to 0. It means that we have to differentiate this function. So we have y is equal to sine cubed of x multiplied by cos of x. Now, as we can see, this is a product of two functions. What are the two functions? We have sine cube of x, and then we have cos of x. So to differentiate this function, we have to use the product rule, which is y prime equals. So we can simply write this as u dv plus v du. So that is the easy form of product rule. So going back to the function, we can let u to be sine cubed of x and v should be cos of x. All right, so what is du? Again, du should be the derivative of sine cube of x. As we earlier explained, we said du should be 3 cos of x multiplied by sine squared of x. dv should be negative sine x, as we earlier defined. So now we can differentiate this function using the product rule, that is y prime is u dv plus v du. So we could go v du plus u dv. So y prime should be, so v du, that is going to be 3 cos x, that is v, multiplied by du, which is cos x, sine squared of x, and then plus u dv. So we know that plus and minus should be minus, so we just write negative sine of x times sine cube of x there. So that is what we get. Oops, this should be y prime. Here we have y prime is equal to 3 cos squared of x, because cos x multiplied by cos x should be cos squared of x, and then this multiplied by sine squared of x, and sine x and sine cube of x is of course sine to the 4th power of x. There, that is the derivative. Now, as we said, since we are looking for the turning point on this curve, and we know that at turning point y prime is equal to 0, so we are going to let this function to be equal to 0. So here we have y prime, is equal to 0. So we have 3 cos squared of x, and then we have multiplied by sine squared of x minus sine to the 4th power of x is equal to 0. Now we have to solve this. So we can clearly see that the common factor right here is sine to the power 2 of x, that is from this and this term. So we have to factor out sine to the power 2 of x. So what is it supposed to be? We are going to do it like this. So we have sine to the power 2 of x into, so this term reduces to 3 cos squared of x. And what about this? So if I factor out sine squared of x, here we will have minus sine squared of x. And all of this is equal to 0. Right there. Now, here we have two functions. So we can write this as sine squared of x is equal to 0. That is the first function. And then the second one is 3 cos squared of x minus sine squared of x is equal to 0. Now we have to solve both of these equations. And the values of x, or the angles x, should be such that when you substitute in this equation, we should get a 0. So we want to find these values of x. Now let's begin with the first one. So let's begin with sine squared of x equals 0. So if I want to solve this function, I have to take square root of both sides. So here, sine of x, we can say is plus or minus square root of 0. And square root of 0 is also 0. So we can say sine of x is equal to 0. Sine of x is equal to 0. Now, remember, let's recall. Recall trig ratio for special angles, that is 0 degree, 90 degree, 360 degree. So we had this, and then we said if we let a particle to rotate, this is the axis of rotation. So we let a particle to rotate from this point of origin to this point right here, about the center. And then we have a line which is called radius. And we let this to form an angle 90 degrees. So this is a right angled triangle. So let's say this is x and this is y. And this rotation in anti-clockwise forms this angle right here. Let's call this angle theta. And what are the trig ratios? So here we say sine of theta is equal to opposite over hypotenuse, which is y over r, cos of theta, which is adjacent over hypotenuse, which is r, x over r, and then tan of theta, which is supposed to be opposite over adjacent, which is y over r, over x, sorry. So we are doing this because we want to recall how to determine the trig ratios for 0 degree easily, or 90 degree, or 360 degree, and so on. Now let's begin with 0 degrees, or 0 degree. So 0 degree should be when this line and the x-axis, or this line has not rotated from the x-axis yet. So the angle is 0. So it's just going to be this straight line right here. So because there is no angle. So in that case, we can see that x should be equal to r. Right here, x is on the, radius is on the x-axis. So we say x is equal to r. Similarly, since this line, the radius, is still on the x-axis, y should be equal to 0. So what does it mean? It means that sine of the angle 0, which is, and we know that the sine ratio is y divided by radius. And we know that y is 0, so this is 0 over r. So sine of the angle 0 degree should be equal to 0, right there. And let's go back here. So from this function, sine of x should be equal to 0. And we know that sine of 0 degree is equal to 0. So here, x is equal to 0. Right there. And I am going to stop here because my domain is from 0 less than or equal to x and less than or equal to pi. And we know 0 is supposed to be less than x, or x must be more than 0. So this is not defined within this particular domain. So I am going to ignore this particular value of x because it is not within the given values of x, because x must be more than 0 and x must be less than pi. So with that being said, I have to continue with this function. So I'm just going to erase this if you don't mind, because this is not my concern for now. So I'm just going to erase it and continue with what is more important. Okay, so, excuse me. So this is where my focus is on. Now, I have a particular one function with two terms. We have cos squared x and sine squared x. Now, if I want to solve this easily, I want this function to be in terms of cos only or in terms of sine only. And recall, let's go back to this side of the whiteboard and recall from simple trigonometric identities. So recall, we said, we know that sine squared of x plus, let me write this out clearly. Sine squared of x plus cos squared of x must be equal to 1. Therefore, if I want this function to be in terms of cos squared of x, then I have to solve for sine squared of x from this equation. So from this equation, we can clearly see that sine squared of x is equal to 1 minus cos squared of x. I hope that is okay. So here, in the place of sine squared of x, I'm going to write cos squared of x. So this is going to be 3 cos squared of x minus. Now, we have to be very careful with this negative sign. So I'm going to put this in brackets. We know that sine squared of x is 1 minus cos squared of x. So here we have 1 minus cos squared of x. And all of this should be 0. There you go. Now, I am going to distribute this negative 1 into this bracket. That is going to be 3 cos squared of x. So negative 1 multiplied by positive 1 is just negative 1. And negative 1 multiplied by this negative 1 right here, this should be plus cos squared of x. All of this should be equal to 0. Now we see that 3 cos squared of x and cos squared of x are like terms. So we can add to get 4 cos squared of x minus 1. All of this should be 0. Now my equation is looks much easier. So since this is in terms of the cos ratio only, I can solve this without any problem. So from this level, we have to solve, start by adding 1 to both sides of the equation. So this is going to be 4 cos squared of x is equal to positive 1. And next, we are going to divide both sides of the equation, that is the left-hand side and the right-hand side, by 4. So this is going to be divided by 4 and divide this by 4. So we can cancel out 4. And then I will continue on this side of I hope it's okay if I erase this because we don't need this anymore. So I'm going to erase this. I'm going to erase this so that we can create more space. The question is, so we have cos squared of x is equal to 1 over 4. Now, since this is quadratic, we can solve by taking plus or minus square root of both sides. So doing so, we have cos of x is equal to plus or minus square root of 1 over 4. There. So it is plus or minus square root of 1 over 4. So we know that square root of 1 is 1 and square root of 4 is 2. So we have cos of x equals plus or minus 1 over 2. That is, cos of x is equal to 1 over 2, and cos of x is equal to negative 1 over 2. Now we want to find the values of x. Now, if I want to find the values of x, I have to take into consideration this particular domain. So x must be more than 0, and x must be less than pi. Now, for the first equation, cos of x is equal to 0. So x should be any angle whose cosine ratio is equal to 1 over 2. As we can see right here, this sign is positive. And in an anti-clockwise, we know that this should be, for this particular domain, this should be in the first quadrant only. Because in the first quadrant, the angle must be an acute angle, right here. So in the first quadrant, it must be an acute angle. So we know that to find x, we have x should be the cos inverse of 1 over 2. Or we know that for special angles, cos of 60 degrees is equal to 1 over 2. So therefore, right here, x must be 60 degrees, or x must be equal to pi over 3. X must be pi over 3. So since for this given domain, x is only in the first quadrant, so we have only one particular value. Because in the second quadrant, the cosine ratio is negative. Now, for the second value of x, looking at this particular equation, we have cos of x is equal to negative 1 over 2. Now, I know that since this is negative, this must be in which quadrant? This must be in the second quadrant, which is supposed to look something like this. I'm going to erase this if you don't mind. So we know that the cosine ratio is negative in the second quadrant. So this is my pair of my Cartesian axis. And in the second quadrant, the angle should look like this. So this angle right here is obtuse. And you know, the sum of this angle and this angle right here, which is acute, let's call this angle. This angle and this angle must be equal to pi, which is 180 degrees. So since my angle right here is obtuse, so the second value of x right here must be equal to this acute angle right here, which is pi over 3. And subtract from pi. Pi minus pi over 3 should be the second value of x. So what is pi minus pi over 3? So this should be 3 pi over 3 minus pi over 3. So since the denominators are common, we can take care of the numerators. So the second value of x should be 3 pi minus pi is 2 pi over 3. So these are the values of x. The first value is pi over 3, and the next one for this equation must be 2 pi over 3. So what do we have to find? We have to find the coordinates of the turning point for this curve. Now we have got the values of x. Now we need to get the corresponding values of y. So let's begin by finding the coordinate of the turning point. So for x equals pi over 3. What is y? Y should be sine. So y is sine cube of x multiplied by cos of x. And then to make this look very easy, I can rewrite this as sine of x all to the power of 3. I hope that is okay. We can rewrite this like this. And this is multiplied by cos of x. Now we know we want to find y for x equals pi over 3. So y should be equal to sine of pi over 3. All of this to the power of 3 multiplied by cos of pi over 3. Now we know that pi over 3 should be 60 degrees. And 60 degrees is a special angle. And we know what is sine of 60 degrees. We know that should be root 3 over 2. So here this should be square root of 3 over 2 all to the power of 3 multiplied by, and we also know that pi over 3, let me write this down, pi over 3 is just 180 divided by 3, which is 60 degrees. So cos of 60 degrees is a special angle. And we know that cos of 60 degrees should be 1 over 2. There. So what is this equal to? So this is y is equal to, what is it equal to? This is square root of 3 to the power of 3, or which is 27. Oh yeah, let's go step by step. 3 to the power of 3. Each of these terms must be raised to the power of 3. And we know 2 raised to the power of 3 should be 8 multiplied by 1 over 2. And 3 raised to the power of 3 is 27. And what is square root of 27? So let me write it here. Square root of 27 is the same as 9 multiplied by 3. And square root of 9 is 3. So this is 3 square root of 3. So here this is y equals. So this is 3 root 3 all over 16. That is the first value of y. So this coordinate point, the first coordinate point right here is pi over 3, 3 square root of 3 root 3 over 16. So that is the first coordinate point. Now, for the next coordinate point, it should be at x equals 2 pi over 3. Now, we know that in the second quadrant, because I do not want to waste my time doing this calculation all over again. Because in the first quadrant, we know that all the trig ratios are positive. Sine is positive, cos is positive, and tan is positive. And the angle is acute. Now, in the second quadrant, as we have studied right here, this angle is obtuse. And then we have to consider this associated angle, which is alpha. So remember we said sine of, let's call this angle here theta. So sine of the angle theta is the same as positive sine of alpha. Cos of the angle theta is negative cos of alpha. And similarly, tan of the angle theta should be negative tan of the associated angle alpha, which is acute. So only sine is positive in the second quadrant. Cos and tan are negative. Now, what does this mean? It means that if, let's say, theta is equal to 150 degrees. So it means that sine of 150 degrees. And in the second quadrant, the angle theta should be 180 degrees minus alpha. Or alpha is 180 degrees minus theta. So if sine of 150 degrees is just the same as sine of 30 degrees, and it's the same for all the other ratios. So it means that sine of 2 pi over 3 is just the same as sine of pi over 3. And cos of 2 pi over 3 is just the same as negative cos of pi over 3. So it means that since this is going to be this, which is the same, this one is only going to be negative because cos, let me write this down, cos of 2 pi over 3 is just the same as negative cos of pi over 3. And cos of pi over 3 is 1 over 2. So for the second, this is going to be negative. So the other y coordinate is going to be negative 3 root 3 over 16. So no need going through all of this another time. So the second point is for x equals 2 pi over 3, the corresponding value of y should be negative 3 square root of 3 divided by 16. So these are the two turning points for this curve at this, for these values of x there. So as you can see, this is quite long and a little bit messy, but if you go step by step, you can solve this without any problem. I hope that is okay. Thank you very much.